This is the recording of our Week 6 Elevator Simulation Logic Circuit assignment. My name is Oliver Birch, and
My name is Brandon Tepperath.
we're going to be explaining how this whole circuit works. So the way we put it together here is that we have 6 inputs and we have the logic converter here. Each of these switches is A through F on the logic converter, and it's grounded before the switches, and it's also grounded after the output at the end of the logic. The way these giant sets of logic circuits were created was by using this button right here, where it will load. It'll then tell me it's not responding, and I wait, and then see, this is the up logic. You can see it overlaps perfectly over here. All right, Brandon, can you explain how the logic is supposed to work?
Indeed, I can. So each of the switches is an input, and they lead to the different circuits with the going up circuit and going down circuit. Um, each the top three switches are the current position of the elevator car,
So it
and
cannot be more than one at once.
that is correct. And the last three switches are where the elevator car is being called to. Depending on the position of the elevator car and where it is being called, the light at the end of the circuit will light up respectively, or if it is going up or going down.
Like this.
And if there is a position where the elevator car is on the first floor and is being called to the ground floor and the second floor, the inputs will be canceled out and it will not move.
Like this. If it's on the middle floor and it's being called to the bottom and the top, then nothing will light up.
And the Boolean equation shows that exactly.
Yes. It's a mouthful to say, but A negative times B negative times C times D plus A negative times B negative times C plus E, and then plus A negative times B times C negative times D times F negative is down output, and it is reversed over here.
Yeah.
Mm-hmm. Now, as for demonstration, of course, we showed that conflicting inputs such as this one will not work. Also,
They
if
do not
the
work.
car is being called to the same floor as already on, nothing will happen. But say it's on the first floor and I'm calling it to the
Yep.
ground floor, then the
It will
going
be going
down
down.
lights up. If it's being called to two places at once, like the floor it's on and the floor below, we've set it to go down. But say I could also call it up, and the going up circuit will light up here. This
Also,
is,
if it is on the ground floor and is being called to the first floor and the second floor, it will just be going up.
yeah, it'll just say going up. And same for the reverse. If it's on the top floor, it's being called down to both floors below it, it just says going down. All of this logic is shown in the logic table I have set up here with A, B, C, D, E, F, and then the two outputs. Unable to have a two output logic going on here because the logic control only has like one output here.
So we had to do each circuit one by one.
But we've just labeled them side by side here. The top part just says on any of the floors, and then one call to any of the other floors, and it shows the logic for that here. This bigger section in the middle is if there are multiple calls. So if it's being called to more than one floor at once, and there's a little tiebreaker here. So if it's being called in opposite directions, it takes the previous output. So if it's already going down, it'll continue going down. We couldn't replicate that in the logic converter here. So we
No,
have,
so we just set it to not move.
yeah, we set it to output nothing. Um, and at the bottom, I just have the part here where if nothing is being called, then there is no output. Q1
Right.
and Q2 is our output 1 and output 2. This was the tiebreaker here. So you can see if it's on the middle floor and it's being called to both opposite floors, and it was already going up, then it continues to go up, and if it's down, it's going down still.
Vice versa, yeah.
Yep. Right. So you can see
Uh,
there's some NOR gates here that are mirrored on this side, a lot of,
there's AND gates,
and then some OR gates at the bottom.
OR gates, yeah.
Yeah. And so all of these AND gates each represent the multiplication, and these OR gates represent the addition in the Boolean expression, true or false expression.
Yeah.
All right, and I think that we've covered everything, haven't we?
I think so.
Yep, we have the VCC set at 20 volts. We were troubleshooting why our lights weren't lighting up, and I thought that increasing the voltage would help, but it turns out it was just the type of light we were using. So this can be set to be 5 volts and still work perfectly fine. For some
Yeah.
reason, blue
It
lights,
seems
it
that
doesn't
red
like the blue
LEDs
lights.
respond a lot better.
Yeah, the red LEDs work a lot better. So yeah, that's the whole elevator simulation. We have this comprehensive um, truth table as well as the
Yep, true
whole
table.
circuit setup right here. And thank you.
Thank you.